Okay, for this video we are going to look at correlations, that word that just seems to keep popping up, and how it relates to scatter plots. So what we have here is we have a picture of a scatter plot, and this particular scatter plot shows the number of hours worked and money spent on entertainment by each of 21 students. So this is kind of going off of a previous video when we talked about that, all right? Also shown is the line of best fit for the data. So they drew in the line of best fit for us, okay? And then all we got to do is just answer the questions below. So in trying to answer these questions, we're going to run across a couple terms and have to explain a couple things here. So let's look at these. So for letter A, it says for these 21 students, as the number of hours increases, so they're talking about X, as X increases, the amount of money spent tends to, well, if you look at this graph here, right, you can see that clearly as you go this way, your Y values also go up. So the amount of money spent tends to, it goes up, right, as long as the number of hours goes up. That's what a positive correlation, especially a linear correlation, means. All right, so let's look at our choices. So we have increase, decrease, or stay the same. Well, obviously it doesn't stay the same, or you'd have a bunch of X's that kind of go straight across that way. And it doesn't decrease because as X goes up, so does Y, so it would be increase. All right, for letter B, it says for these 21 students, there is blank correlation between the number of hours worked and the amount of money spent. So the way you can always remember that is if there is a relationship, it's either going to be positive or negative. All right, positive means that as X goes up, so does Y. So in other words, your graph is going to go up from left to right. A negative correlation is as X goes up, Y is going to go down. So they do the opposite of each other, right? Whatever X does, Y does the opposite. All right, and then so let's look at what the options are. So it says there is a positive correlation, there's a negative correlation, and there's no correlation. All right, well, there is something going on. No correlation would mean that you had like a blank scatter plot with no ability to draw any kind of lines or connections between things. There's obviously a connection here, and as X goes up, so does Y. So again, going back to the language we use, that is positive, right? Positive correlation. And then using the line of best fit, we would predict that a student working 12 hours would spend how many dollars? So all you gotta do for that one is find out where 12 hours is. So it's right here. And then go up to the graph. So let's go up to the graph. And then we're going to pick the number that closely mirrors that. So it looks like if we go up here, it looks like we're below 30. We're well above 25, but we're below 30. So let's see what options they give us. Well above 25, but below 30. The only one that works is 29. All right, so let's pick 29 and let's see what it says. And it likes it. All right, let's try one more problem. Okay. All right, so on this problem, let's just look at the shape of the graph. There is a correlation, so it won't be no correlation. It'll either be negative or positive. Well, as X goes up, Y does the opposite and it goes down. And from what we've talked about, that is a negative correlation. So I know that for B, for these 24 students, there is a negative correlation between time spent texting, time spent exercising. Let's do A. For these 24 students, as the time spent texting increases, in other words, as we're going this way, what happens to Y? What happens to your time spent exercising? Well, as you go from left to right, it goes down. So the fancy word for down is decrease. It decreases. All right, and then for C, using the line of best fit, so looking at this line, we would predict that a student texting for 4 hours would exercise for how many hours? So let's go over to 4, where texting is. And then we go up and meet the graph and then see what number that corresponds to for time spent exercising. And that looks like it's well over 5, but not quite at 6. So approximately, yeah, let's use 5.8, right? Well over 5, but not quite 6. Check that. Bang. All right. Good luck with these guys.